Welcome to Code Interpreter. This video is continuation for previous video of Java introduction. So if you have not watched my previous video, link is provided in the description. Please watch it. So this video we will learn more about Java execution and compilation. So we will discuss what is JDK, JRE and JVM, and also major differences between JDK, JVM and JRE, and also what are the most frequently asked questions we'll see in this video. So let's jump into the video. First, what is JDK? So JDK is nothing but a Java development kit. So it is a development environment, especially used for it is used by the developers only for developing the Java application. So it's a core component of Java environment, and JDK is a platform-specific software. So that's why if you see any of the installation pages, we will have the installation of JDK separately for each operating system. For Windows separately, Mac separately, Unix separately. So that's why we call this as a platform-specific software, and it provides an environment to develop and run the Java programs. So it contains this is nothing but the development environment. Like it provides a development environment, which is nothing but the JRE. So it contains the development tools like compiler, debugger, and all this will be present inside this. And along with that, we have environment also, which is a runtime environment. And this runtime environment consists again of JVM. This is about JDK, like what we have inside this JDK. It provides environment to develop and run the Java program. It contains Java development tools like this, and also it contains a JRE, which is a Java runtime environment. And we can say JDK is a superset of JRE, as it contains JRE with all the tools that are required. And now let's see what is JRE. So this JRE is again is a runtime environment. It is an installation package. It provides a platform to execute Java program. So it includes JVM and necessary runtime libraries. So suppose it contains integration libraries and language and utility libraries. So integration libraries are nothing but for your Java program. If you want to connect to database connectivity, you will use JDBC and all that stuff, right? So this is again this is nothing but a integration library, which through which you are connecting to a different service through your program. Similarly, it contains the language and utility libraries also. If you want to execute a Java program, you can install only JRE. If you don't need JDK, because you are not developing or compiling the source code, right? So you are just executing the program. Now let's see what is JVM. JVM is a Java virtual machine. It is main component of Java programming we can consider. When we execute a Java program, JVM is the one that actually calls the main method. So for every Java program, main method is the entry point for the execution to start up with. So JVM is responsible for executing Java bytecode, like it considers the input as a bytecode. What when during the compilation process, .java file will get converted into .class file, and the .class file will be taken by JVM as an input, and it tries to compile and interpret it, and it gives the final execution. It completes the final execution and gives the response. So it provides a runtime environment for the applications to run, we can say, and it is virtual. Why we are calling it as a virtual is because it provides an interface that does not depend on any underlying operating system. So if you remember in the previous video when we were discussing about features of Java, one of the major feature of Java is that Java is a platform independent language. You can write it once and run it anywhere. So JVM is the one that is responsible to satisfy that feature. So you can execute the Java program which you got it which is developed in any environment. Like if you taken a Java application which is developed in Mac machine or Linux machine, you can execute it anywhere. So JVM is responsible for executing that anywhere. So it satisfies the aura. We call it as a aura. This is all about JVM. Let's execute one sample program. Here I am using Notepad. So let's write the starting. First, you need to give the class name. I'm giving the class name as first code. Close this class, and inside this class we have to declare the void main method. So all these are access identifiers. So we'll discuss in detail. So for now, you just execute the main program. Inside method, I am just adding one sysout statement. I'm just printing like this. Okay. Now, first we need to save this file. Okay. So in order to save this, we need to give whatever the class name that we have given over here. We should always save the file name with this class name only. And extension should be .java. Okay. So let's save this. It got saved over here. Now let's execute this, let's run this program. How we will run is either you can use command prompt or you can use any IDE is like where you can visualize its editor along with it comes up with a development environment where you can run your programs also, you can compile, you can debug everything. So for now I'm just using command prompt. I'm navigating to the location where I have this file present. Now, first, in order to start up with, there is a two processes as I mentioned. First is the compilation and then the execution. So, in order to compile, we have to issue Java C and the file name. Okay, so if you have any compilation issues, it will throw error here itself. Since the code which I have written, it doesn't have any compilation issues. Let's introduce one error. Okay, I have removed the semicolon. In Java, it is mandatory for to have semicolon for each line. I just removed it. I have saved. Let me recompile it. If you see, it has thrown a compilation error saying that error at line number 3, it is expecting semicolon. So this is how we will, during compilation errors, during compilation, we can get the compilation errors. If there is no error in the code, it will not throw anything. Okay. Now compilation is done. Let's go back to this thing. If you see, it has generated the dot class file. And if you try to open this dot class file, you can see this is in uh, this is in bytecode, like we cannot understand this thing easily. Okay, now let's try to run this thing. While running, you don't need to give any extension, it will automatically pick the dot class file. Okay, just give Java class name, it gives the outcome. So now let's come back to the PPT, like what we understood from this. So first we are doing the compilation and then we are executing the program. So which component is doing what? Okay, so the code that we have executed now, right now, what we have done, we have written a small Java program. We have compiled it using Java C, and the outcome from this is a dot class file got generated. This dot class file is nothing but the bytecode. It contains all the bytecode. So this bytecode, so till here, it is a responsibility of JDK and JRE. Okay, because compiler, debugger, and all this present inside the JDK environment. Okay, and the runtime gives the it takes this Java program and it performs the compilation process. It gives the final outcome. It gives the bytecode as an outcome, and this will given as an input to JVM. Internally, JVM contains three different components. These are the major components: class loader, runtime memory or data area. This is also called as memory management and execution engine. So inside class loader, what happens is this bytecode class will be loaded, it will be linked and it will be initialized, verified, everything happens inside this class loader. So if what it loads and what it verifies is, during loading also we might expect some bootstrap error also. If it verifies whether the bytecode that we have received is proper compiled code or not. Suppose if you have written a Java program, if you have compiled it using Java 21 version, but when you are running it, you are using Java 8. So there will be a mismatch, right? So it will fail during this phase. Next phase, what we have is a memory management. Internally, this has method area, stack area, heap area, program counter registers and native method stacks. So whatever the code that we have written, so that code will it will there will be some memory that is allocated inside JVM for that. So all that memory allocation happens inside this runtime memory. And next, what happens? It executes after allocating. It means like it has it has given some memory to it. Now it will process into a execution engine. Inside execution engine, we have compiler, interpreter, and garbage collector. So compiler, here the actual transformation happens. The bytecode that we got it will be converted into a machine specific code, which is nothing but the binary forms, zeros and ones. That conversion happens over here in the execution engine. And while after that, whatever the memory that is unused will be removed using garbage collector. Next we have is the Java native interface and Java native libraries. Suppose if your application is using some native libraries which are built using C or C++, that will be fetched using those libraries will be fetched using Java native interface. So this is all about the JDK, JVM, and JRE. What internally each component does. Next, we will move to the next section called like what is the major differences between JDK, JRE, and JVM components. This is one of the most frequently asked interview question. So, what JDK, JRE, and JVM? What we have understood from this session, we'll see. So, what is a JDK? JDK is nothing but it contains development tools and JRE environment. And JRE is it contains libraries and JVM. So, what are the libraries it contains? It contains integration libraries to connect to JDBC or RMI, and we have other libraries like util libraries and RTJAR, all these things present inside JRE. And we have JVM. So whatever we got, the bytecode that we got over here, it will be prodded to JVM, and the actual execution happens inside JVM. So JVM is completely a runtime environment only. So whatever the compilation that happens here, the compiled code will get executed inside JVM. And who uses JDK? JDK is mostly used by the developers to write, compile, and debug the Java code. So all because it contains all the development tools. Next, what JRE is used for? JRE is mainly used for execution only, and end users who wants to run the Java applications, they use the JRE. And JVM is completely a runtime engine as mentioned. It executes the Java bytecode. So inside this JVM only, the transformation of bytecode will be converted into a machine specific code, and we get the result. Next, what is the other difference? The JDK is completely a platform dependent. It means like if you see when you download the JDK or JRE, you will for each operating system we get different installables. For Mac, we get a different JDK installable. For Windows, we get different one, and for Unix, we get different one. Like that, it's a platform dependent. Whereas both JDK and JRE are platform dependent, whereas JVM is platform independent. It means this is one of the main feature of like when in the previous video when we discussed about features of Java, the first feature is Java is a platform independent language, and it is nothing but ORA, write once and run anywhere. So you can run the Java code on any environment. So you can whatever the Java code you have written on Windows machine, you can execute that thing in a Mac machine. So it is completely a platform independent. So these are the major differences between these three components. I hope you understood all these concepts. If you like my video, please subscribe to it and share it with your friends if you feel informative. And see you in next video. Thank you for watching.